Hello, my students. Welcome to this topic, the Bragg's law. So we have studied electromagnetic waves and the properties of X-rays in our previous sessions. Let us know what happens when the X-ray is incident onto a crystal surface by learning the Bragg's law. So in this topic, we are going to learn how we can derive this Bragg's law. So the Bragg's law equation is given by 2d sine theta is equal to n lambda. 2d sine theta is equal to the n times lambda. So this is the formula that we are going to derive. So the hypothesis is to imagine that Bragg's diffraction is a reflection on the imaginary plane mirror. So we are going to assume that the planes that are in crystal are plane mirrors. So which means that when these X-ray beams are going to be to reach these planes, they are going to be reflected. So where we'll have the angle of incidence and the angle of reflection. Then these imaginary planes contains atoms which the X-ray beam is diffracted. So these X-rays, when they meet the atoms in these planes, they are diffracted. The imaginary plane are identical to each other. Thus, the distance between them is d. So the d is the distance between these planes which are present in the crystal. Now let us consider this diagram. We have the incident beam and the diffracted beam. So the beams that we are using here are the X-ray beams. So these beams have the wavelength lambda, and the angle of incidence is theta. Then because we are using, or we are assuming that these planes are the plane mirrors, so it means that the angle of reflection will also be theta. So these planes are separated by the distance d. The two X-ray beams with identical wavelength approaches the imaginary plane mirrors. Then they arrive in phase with an angle of incidence. So in phase means that when the trough meets with the peaks at the same time. So the peaks and the troughs, they occur at the same time. So in phase is the opposite of out phase or out of phase. From the diagram below, the wavefront OF is equal to the wavefront OH. So we have here the diagram where the X-ray beam are coming to these planes. So they are reflected after reaching these atoms in the planes. So we have seen the distance of separation between two planes is d, and we have the wavefronts OF and OH. In order to obtain a cooperative effect, the diffracted ray must be in phase. So when the diffracted ray is in phase, it means that the sum of Fg and Gh is the integer n wavelength of the wavefronts. Therefore, the sum of Fg and Gh is equal to integer n times the wavelength. This means that Fg plus Gh is equal to n lambda. But from the diagram, Fg is equal to Gh. So we are going to use the trigonometric ratios, SOHCAHTOA, sine, cosine, and tangent. So here we are only going to use the sine. So sine is equals to opposite over adjacent. So from the diagram, we have seen that the opposite is Fg. Then from the other triangle, the opposite is GH. So we have the first triangle FOG and the second triangle OHG. Then sine is equals to opposite over hypotenuse. Sin theta is equals to FG which is the opposite of the first triangle, over the hypotenuse D. So these two triangles are sharing the hypotenuse. So the second triangle, we have sine theta is equals to GH over D. So D is the hypotenuse. So here we have, we want to make FG and GH be the subject. So from the first one, we have D sine theta is equals to FG. Then from the second triangle, we have D sine theta is equals to GH. Then from the above, we have said that FG is equal to GH, which is also equal to NR, N lambda. So here it means that FG is equals to GH. Then all of these two are equal to N lambda. So it means that we are going to take D sine theta plus D sine theta to be equal to N lambda. So this means that when we add this D sine theta and D sine theta, we get 2D sine theta, which is equal to the N lambda, where we have N representing the order, or N is the integer representing the order. Then lambda is the wavelength of the X-ray. Then theta is the scattering angle. Then D is the interplane distance of atoms. Thank you for listening to me.